Moving on to example 2 of using multiple iterations of the chain rule to derive composed functions. So here we're trying to derive sine squared of x squared plus 1. Okay, so when we see a squared or any power on sine, the first thing we want to do is convert this to a giant power of everything involved. Okay, so anything involved with sine, you square it. So what does this give us? This gives us d dx, big parentheses, sine of x squared plus 1 squared. So we basically just moved that 2 on the sine and moved it out to the outside inside of a giant set of parentheses here. Okay? Just notation changing. That's all we're doing. All right. Now notice that we have iterated functions being composed here. So we have an inside function, which is x squared plus 1. We have a slightly less inner function. This is the sine. And then on the outside, we have all of this stuff squared. So we have 3 functions being composed here. But the method that we use to derive this works exactly the same way as all the previous examples, except we just have to use multiple iterations of the chain rule. That is, we just have to use it multiple times. So the outside function in this case is the red thing. So it's the parentheses squared. The inside of what's inside that red function is the entirety of that sine stuff. So that's sine of x squared plus 1. That's what's inside the square. Okay? So let's use the chain rule as we normally would. So this gives us derive the outside. So we just bring the 2 down in front of everything. Nothing unusual here. It's just 2 times blank to the first. Then you copy paste everything that's on the inside. Okay, and then now we have to multiply by the derivative of the inside of this, meaning we have to derive this thing. But in order to derive that, we have to use the chain rule again because we have a function on the inside of this sine. All right, so outside of this, of the green underline thing, is the sine of blah. The inside is the x squared plus 1. All right, so we have to multiply this black stuff here by the derivative of the sine first. So we derive the sine. So this gives us cosine of x squared plus 1 because we're going to leave the inside alone. Okay, then you multiply by the derivative of this inside. So this gives you 2x. All right? So that's how this all goes down. That's it. That's the end of the problem. So all of this stuff was the derivative of this green underline here. Okay? And then this 2x right here is the derivative of the thing on the inside of the cosine. So this is kind of why it's called the chain rule, because these are all linked by their inside functions. All right? So that's the key idea with this sort of problem. With this, you can call this problem done. However, let's redo this, but a little bit faster. Instead of listing out all the inside and the outside functions, let's see if we can just do this very rapidly without listing anything. So it's kind of a bit of a challenge. So let's start with right here, because the conversion is going to be the same no matter what. So we have d dx sine of x squared plus 1 squared. All right. So let's derive this. Derive the outside first. So the 2 gets pulled down. We have things to the first power, copy paste the inside. Now the goal is to derive this thing. So to derive that, you have to derive the sine part, because that's the outside function. So you have times cosine of x squared plus 1, because that's the inside of the sine. So it gets copy pasted. All right. Then you multiply by the derivative of the inside of this function here. So this gives you 2x. And that's it. It's a one-line problem. Once you get the hang of knowing what the outside function is and the inside function, you can do it automatically. No extra writing, no writing outside and inside and all that stuff. You can just do it all in one line. Okay? So hopefully that made sense. We have several more examples to go. Check those out if you're still in need of help and things are a little bit confusing still.